The next thing we want to talk about is modeling principles. Now, if you remember correctly, we talked about how modeling is not done by every process model. And in some cases, the modeling is done as part of the design. So we're just going to talk about these in general and realize that it may fit into different parts of your process model depending upon which model you're using. Now, the primary goal of a software engineering project is to build software, not models. So while building models is great, if it doesn't get you towards the process of building software, then it's not helping. So keep that in mind when we talk about some of these modeling principles. Now you might think, well, what is a module? A module is something that looks like your final project or allows you to describe your project, or at least part of it. It helps you define what you need. Think about for a second an architect, which builds a model of the office building that they're going to use to show people who can't read blueprints. This is a good example. So let's look at these principles. The first is travel light. That is, don't build more models than you need. By only working on the models that you're going to write software for, you minimize unnecessary work. Think about solving a physics problem where you have lots of information and you solve for every possible thing that you could have. Well, what happens if you only need part of it and you did all this extra work? It would be meaningless. Focus on what you need. Create your models for that. Next is to build it simple, but no simpler. This is a play on Einstein's saying about simplicity. Keeping the model simple will also most likely keep the code simple. But don't be so simple that it doesn't do what's really needed. Next is to build models in a way that are amendable to change. Since change happens, keep with a process that allows for change. This is especially important with agile projects. The next thing you need to know about your model is you need to be able to explicitly state the purpose of that model. Why does it exist? Where does it fit into your project? You need to adapt models you develop to the system at hand. Different types of systems are going to require different types of models. Build the right type of model, not just the type of model you're used to. Next, try to build useful models, but not necessarily perfect models. Time spent building on a model is not time spent developing code. So get your models close, get them good, but don't worry about making them perfect. If you're looking at your model and your instinct tells you that it isn't right, you're probably correct. Learn to listen to your instincts and learn to do a deep dive into a model if you think something's wrong with it. This may mean that you're doing it, or it may lead into our next principle, which is to get feedback as soon as you can. Depending upon what type of model you're using, feedback may be from other developers, your customers, or both. Now, if modeling is part of your design process, I want you to keep these extra principles in mind. First is your design should be traceable back to the requirements. Look to your requirements and build from there. Next, consider the architecture of the system being built. Your model doesn't exist in a vacuum. Let it look at the bigger system in general. The design of the data is as important as the design of the processing functions. How and what you store is very important. Interfaces, both internal and external, must be designed with care. This is how data is going to be shared with other systems and even internally. And thus, it may be used by members outside of your team, which won't be able to communicate as easily and quickly with you. The user interface, or UI, should be tuned to the needs of the end user, not yourself. In every case, it should stress ease of use. Well, almost every case. Facebook is actually an interesting user interface story because it goes against this convention. They have actually intentionally made Facebook hard to use. The purpose was so that you learn how to use it and you can remember how to use it. So a little bit of pain up front makes it easier long term. Next is component level design should be functionally independent from all other components. Therefore, components should be loosely coupled with one another and to the external environment. That means that basically they should be able to stand alone. As long as you know what inputs need to be fed and outputs should be gotten from your component, how it does its thing, its little magic black box, should be fine. Your design models should be easily representable, and your design should be handled iteratively. So just as you're going through your regular process, you're going to be coming back to design. Don't be afraid of handling that and getting more and more detail as it goes along. The creation of a design model, therefore, is not precluded by an agile approach.